Alright, today I will be talking to you about how the United States electric grid runs and operates, and how we can improve the infrastructure of the grid so that the flow of electricity in and around the United States runs smoothly and will continue to run smoothly in the future. Now, the big part of why people talk about the grid is that it is an aging infrastructure that has been around for quite some time within the United States, and there basically needs to be a upgrade and major reconfiguration of the grid so that the United States can stay competitive and so that the economy can continue to hopefully grow because of the large demand that consumers and industry now puts on electricity today. So I will be talking to you today about the current state of the grid, the issues that need to be addressed, and the problems that we currently have with the grid, and how we can hopefully improve those problems. Now, the so-called grid within the United States all began way back in the 1880s with the war of currents, which is between AC and DC power. And basically, direct current, as we know, is just continuous flow of current in one direction through a circuit, and alternating current is an alternating source where you get switching back and forth of polarity to switch current in both directions back and forth at whatever frequency you have. So, in the end, AC current won out because the major advantage people saw was that they could easily transport AC current over longer distances just because it required less infrastructure and you didn't have to have as many substations and transmission stations to keep the voltage high enough to get power on the other end. So in the end, due to the support of people like Thomas Edison, Nikola Tesla, and George Westinghouse, Nikola Tesla and Westinghouse won out because they were the supporters of AC, so the major system of the electric grid was set up around that. Now, the grid today operates in this way, and it all starts at a power plant, and that's where the energy is produced. And in most cases, except for maybe like hydropower, a lot of the turbines used to mechanically convert energy into electricity are through steam turbines. And so we use resources such as coal, oil, or gas, or even nuclear material to superheat water, which causes massive amounts of steam to flow through these turbines and spin them, which ultimately produces electricity. And the electricity that comes out of a power plant is AC, so then what it does is it goes through a transmission substation that steps up the voltage to around 10,000 volts so that it can travel longer distances over the high transmission lines. And then once it reaches its local regional destination, there's separate power substations that step the voltage down to around 10,000 volts to then be transported locally within a neighborhood or a region to the customers. And that's where we see the small power lines along the roads, and they reach small transformers that you'll see on the edge of on the edge of your street or near your house that will step it down once more and convert it to a better voltage for consumer use, which is around 120, 110 volts at 60 hertz. So that's the way the grid is set up today and how it still basically continues to operate. Now, the problem with this setup is that, as we saw in the picture, it's all about regional distribution of power, because originally all it was is you'd have different regions, and every region would have their own power plant, and each power plant would produce enough electricity for the local region, depending on however it did that, coal, gas, oil, and then distribute it to those in need around them. But ever since the 1960s, things have been going in a different way. And so the grid infrastructure of the 1960s really doesn't hold up to today's standards because of the fact that now energy, because the energy produced is now privatized, so the energy produced is now sold off at the cheapest rate to utilities, which are the ones that purchase the electricity from that power plant and then, of course, sell it to us, and we're the ones paying for the bill. We pay the utilities. So they're the ones that are purchasing the electricity at the cheapest rate from maybe like a gas plant or a coal plant out in West Virginia or Wyoming somewhere that can produce electricity for like close to nothing compared to the resources put in, and they can make a good profit off it, and we pay less for it. And the problem with that is now you have this idea of exporter and importer states. So now you have states that don't really demand a lot of electricity exporting a lot of it because they're the ones producing it, and then importer states, especially ones like California or Florida, Texas, New York, especially anywhere in the Northeast region, importing all this electricity into one area. So that basically is causing a lot of problems because you're putting a lot of stress and strain on the grid in that location. And also the fact that, like, everybody talks about green energy and, you know, producing energy in a cleaner, more renewable way with solar and wind, for example, but granted those are great and we're doing those very well, but the transmission systems used aren't exactly the best because of the fact that there's a lot of loss of energy and we can't really store it that well, and energy produced at peak times may not be enough to support the demand, so that can lead to congestion and blackouts. So this is just definitely not how our grid was meant to work. And as I mentioned, like, a very concerned area is the Northeast region, because as you can see, have like big cities, very heavily populated: Boston, New York, Pittsburgh, Philly, Baltimore, Washington, and these are all, you know, taking in electricity from further states, such as like West Virginia and areas that aren't regional. So the grid is taking a lot of stress in those areas, and that's called congestion. And basically, when the grid and the power lines and transmission lines are overloaded with electricity because of the high demand, especially like in the summer with everybody running AC, you know, you just have blowouts and blackouts in your grid, and that's what causes loss of electricity. So that's the major concern, especially as technology advances and demand increase. Now, people say, well, then how come we haven't done anything about it yet? Well, there's three major issues, and they are, number one, the cost. Like, it takes a lot of money and resources and capital to try to establish a system such as this. So, you know, just like as anything, if you put money into something, somebody has to pay for it. So that will cause trickle down for the customer as well. And I don't know about you, but I know my parents and plenty of others don't want to spend more money on electricity just to improve a system if it works now, because most people are just thinking the now, and that's all they're worried about. Also, as I mentioned, utilities are now, you know, making a lot of money off selling energy and providing us with electricity. So if they're the ones that have to work together to try and reconfigure the grid, you know, they could be losing profits, because instead we'll start focusing it more on a regional basis again, and instead of just like being able to sell electricity to like far out places, not local to them, they'll have to like consolidate and stick closer to home, which means less money in their pockets, so they're not always for it. And just as anything else, like, locals are always against change, and if it means installing a high voltage capacity line in their backyard, they're probably not going to be for it. So you get a lot of resistance among just neighborhoods as well. So basically it comes down to just nobody wants to work together whatsoever. Now, suggested upgrade for the grid, if something were to be done and should be done, comes down to three basically major installments and reconfigurations, because it comes down to, like, we can't just keep fixing and patching the small areas that we see definitely need attention, because in the end it's just going to cause a waterfall effect, and you're just going to have to keep patching up these little areas, but you're never really solving the big issue. So the number one upgrade would be improving the extensiveness of the grid by installing high voltage capacity power lines, and they can carry a lot greater electricity flow over longer distances. So now you would be able to, like, send electricity and take electricity from further reaches of the United States, which we do now, but at a more reliable efficient rate, so that way you'd be able to meet energy demands wherever you are. Secondly, you would want to make the grid more digital, because if you're able to digitize something, you're better able to analyze how something works. So therefore, if you can put it into data, you can turn that data into information and then analyze it and like really get a better insight into how your systems are working in general. And therefore, if we were able to do that, we can install monitoring systems which would be able to keep track of where the electricity is flowing in and out of, and where you're seeing bottlenecks and congestion, and where you can specifically target your efforts to try and keep the grid, working A-OK. And this would create a smart grid, which you often hear companies like IBM talking about, smarter planet. Like this is what they're referring to. And this is a perfect example, is make everything within the system, the plants, the distributors, utilities, power lines, customers, all have systems that can monitor what they're outputting and inputting, so that way they can talk to each other and better predict what's going to happen in the grid to keep it working smoothly. So overall, the increased demand, basically due to economic growth, new companies, new technology, has led to massive, massive strain on the United States electric grid. So therefore, there's a fear of major blackouts, and because of this congestion, so we need to increase our capacity lines, set up more monitoring systems, so that we can create a reliable, efficient system, which basically would take care of the problem. But in order to get this done, we definitely need desire and motivation from the public, politicians, government, and utilities providing the energy, so that we can all work together to find the common solution. So, any questions or comments?